Testing React components. First thing, I actually want you guys to meet my friend, Adam, and no offense to people who, if anyone's named Adam over here, because Adam's lately been feeling like this, right? So Adam was a developer, and he got promoted to a lead position. So he was given a big challenge saying, hey, we want you to improve the quality of our product. So he undertook this initiative of improving quality, and he became a team lead. So things were great. So he loved the added responsibility, but he's still starting to feel like this. So why? What happened? Basically, they invested a lot into automated testing, but they didn't really see a lot of improved quality come out of the efforts. Second thing, even the dev productivity was not very good. Not as what they expected. And lastly, the users were slightly happy, but they were not like very enthusiastic and say, hey, you guys did an amazing job, right? So Adam's thinking, I invested a lot of time and effort, my teams did a lot of work, our company did a lot of work, but what happened? So before I answer that question, let me introduce myself. My name is Avindra Fernando. I'm a senior software developer working for a startup called 1HQ in the Kansas City Metro. And you can follow me on Twitter and Medium, and that's my GitHub. So going back to Adam's case, what happened? So to answer that, here's what I call the testing ice cream cone. So this is, oftentimes we see companies have a model like this when it comes to testing, where you do some level of unit testing, but not a whole lot across your tech stack, and you have a little bit of service tests or integration tests as we call it, and then you have a lot of UI automation tests, but you still have certain departments, so the QA department or the QA teams still running a lot of manual tests. So these are, you document the test plans, you have step-by-step instructions, and you still run through a model like this. So the challenge with a model like this is the more you go up the ice cream cone, the test runtimes are much slower. The feedback loops are much slower. So then this is what Adam had before he took on the position. So he said, okay, let's try this model. So the first initiative was, let's automate all of our manual tests. We don't have any manual tests. And then, so all of them were converted to UI automation tests. And then there was a big effort, a significant effort on improving the unit testing coverage, right? And they ended up with this. Now, the problem with this is something like this. So you have two units working really well, but when you put them together, they collapse, right? So unit testing alone didn't give the benefits that they were looking for because they kind of neglected the middle tier of integration tests or testing two units, do they work as intended? So here's an example of how long the tests took. So the unit tests were passing very fast. There were about 500 of them within less than 2 minutes. But the regression tests, 58 of them, took a longer time. So we can see that 4 failed here, but the feedback, it was like 56 minutes later is when you hear it back. And some companies, this is actually a pretty good scenario, but in some companies, I've worked for companies where this loop took days for them to hear it back. If something's wrong with the code you wrote, right? So the answer is, let's say hello to what we call the testing pyramid. So here, the idea is we revert the ice cream cone and then increase our testing coverage using a lot of unit tests, and then we have the service level test covering testing all those units together, and then finally, whatever we're not able to cover using the service test and the unit test, we have a UI automation test. So this is, I would say, in the perfect world, this is what companies would strive towards. So how many of you are familiar with this or heard about this? Cool. So since we're on a React meetup, we got to talk about Ken C. Dodds. Ken C. Dodds took it a step further and kind of came up with a testing trophy, where it's the same idea, but he also points out that static testing, so static testing is basically you're linting and making sure that you don't have when you write code, there's no grammar errors, right? It's basically checking if you're writing good style and covering it there. But above the trophy, it's exactly the testing pyramid. So when this type of initiative is proposed, when this type of initiative, first question that you get is, it's going to slow things down, right? Isn't unit testing going to slow things down? So to answer that, let me give you an example from our day-to-day world. So does anyone know what this is? Or have seen one of these?
435 in a row.
Yeah.
I can't remember what they're called.
Yeah.
Diamond
Yeah.
version.
Yep, it's called the double crossover diamond, and it's actually very close to my work, 435 in a row, but they're building more and more. This specific one, does anyone know where this is from? This is the very first one in the United States. Springfield, Missouri. Yep. Yeah, so the idea was the Missouri Department of Transportation came up with one of the issues is how do we make sure that we have more throughput flowing through these intersections, and also how do we make sure that we avoid a lot of accidents and things like that. So if you look at the conventional diamond, we have 26 conflict points. So a lot of starting and stopping. If you're lucky, you get all greens and you can go, but oftentimes that's not the case. And you also have a lot of conflict points, so more chances to collide with another vehicle. With the double crossover diamond, it actually only has 14 conflict points. So it reduced the number by close to half. But the caveat here is you can't zoom through these things, right? You've got to slow down. So the same idea that I would propose for unit testing. In the beginning, this initiative, yes, it will slow your dev efforts down. But the payoff will come in a few months, few years. That's where you'll start seeing a lot of speed up, and your dev teams can go much faster, deliver code, and deliver high quality products much faster. So how do we do this in the JavaScript world? The first thing is we need tools. So the first tool we need is a test run. So Jest, who's using Jest? Yeah, I was expecting a lot of you to use Jest. So Jest is what I would say one of the most popular testing frameworks for JavaScript right now. And one of the reasons why it actually became really popular is because it's so easy to use. It's very easy to configure. You get a lot of things out of the box, and also it runs tests in parallel. That's a really cool feature that you get. You probably don't get with other frameworks out of the box. And the last one I would say is it actually doesn't need a browser or a headless browser to run your tests. It runs on something called the JS DOM, which is basically a simulated. So the community created this library called JS DOM, where they have a lot of browser-like features, which we would need for testing. So it runs much faster and needs very little setup. So in the 2018 State of JavaScript survey, we saw a lot of interest, a lot of hype about Jest, and a lot of people saying, hey, I've heard about it and I really want to use it, right? They kind of, I would say, beat the other frameworks out there because of all of these added benefits that it was adding to the community. So here's a very simple test. All this is really doing is checking if two numbers are giving the result. So if you're familiar with how you write tests for even other frameworks, I think it's very, very similar. You import your function, and then you have a test wrapper and pass in a method to it, a function to it, and then you write your assertions. You can use the keyword test or it, that both are synonymous in the context of Jest. Async request, no problem. You can handle this as well. So here we have an example of a function called getUsername. You pass in user ID, and you want to get the name of the user. It's calling a function called request. Request basically is returning a promise, making an HTTP request to an endpoint, getting the results back, and displaying it. So the first thing we need to do if we want to test something like this is create a mock. It's very easy with Jest. So the first thing is you create a folder by default called under mocks under. You can configure it, you can give it a different name, you can do all of that in Jest config, but basically, and then you create your mocked implementation of request.js in this example. Just make sure the file name and the function name is the same. So yeah, here we've created a mock, and it's basically returning a key value pair of ID4 and an object which has the name within. So finally, if we want to test it, let's make it, you tell Jest where to find that mock. So simple as just mock and giving a reference to the request file, and then you can write your test here. So basically this is now passing in the value 4, and if you remember from my previous slide, value 4, the name was Mark, so it's just asserting that it's Mark, right? So pretty straightforward test. How is it going to look on the console? Pretty similar to this. I really like it because it gives a lot of information to you up front, and so you can easily debug, test, and things like that. But if everything's passing, you see here a use case of 7 or 8 tests running at the same time. So that's basically the parallelization that I was mentioning earlier regarding Jest. All right, so now let's take it a step further. Now, how do we test our UI components, right? How do we test our React components? So first thing is, let's identify what are some different types of tests that we can run. The first one is what I call a smoke test. So smoke tests are basically checking, hey, is your app reading, right? Is it rendering? I don't care what you render. I don't care about the values that you render, but are you like alive? Basically, that's a smoke test, and you can have different scenarios for smoke tests. The second type of testing is what we call shallow rendering. So the idea here is when you create React components, you oftentimes will have components which is a parent component, and you'll have a child component, a child component, and so on. But shallow rendering, the idea is let's just test that one component or the parent component, it's by itself. I don't really care what else it's calling. So the concept is only let's test only that. And the other final thing is full rendering, where you actually test parent component, children, grandchildren, so on. All of them needs to be fully computed. Okay, so here is an example of a smoke test. So this is basically using render and rendering your app and checking, hey, did it render? That's it, right? So very straightforward. This would be one of the most straightforward tests that you can have as far as a smoke test goes. The second one is the concept of shallow rendering. The shallow rendering, one of the famous libraries which support it is called Enzyme. So what you do is you can say shallow app, and this will only render and check for the app component, but not its children. So this test is basically checking if it rendered, but you can actually extend it and test a couple more. But everything should be related to that one component. Now, Ken C. Dodds actually saw a problem with this approach. The problem was you can actually refactor your implementation details, and your test would still say, and your test would break. And also you can basically mess with your application, but your test will say everything's fine, right? Because here, what we're missing is we're not testing as how a user would discover and find and interact with our elements or components in that page. Shallow rendering had a problem, so Ken C. Dodds said, he wrote a big blog post about it, mentioning why shallow rendering is not the way to go. So not only he pointed out a problem, but he actually proposed a solution. So does anyone know what the solution was?
Testing rendering.
Testing. Yeah, well, in the beginning, it was called the React testing library. And then I think the community realized that most of these concepts are not really specific to React. That's one way to test React, but these are all generic concepts. So then the testing library was born, and then all the other frameworks will now benefit from it. including if you're still writing vanilla JavaScript applications, you can still use the testing library to test against DOM nodes. Yeah. So the testing library is built on top of certain guiding principles. So the first one says, if you are dealing with DOM nodes, then let me check against that, right? That's what I was saying about, I don't really care about shallow rendering, because shallow rendering doesn't really give me a good reflection of what really happens when the app is fully rendered. So I would say, summarize it like this, like test it like the user would find it, the user would discover it, the user would actually interact with your components. So pretty simple principles. The last principle is, if you're contributing to the library, make sure that the APIs and the functionality that we provide are simple and very easy to use. So we know if you give people a simple library and a fast solution, you get a lot of adoption. That's why I think Jest was very successful, because of zero configuration and the nature of, you just don't have to do a lot of complex things to achieve what it's telling you to do. How to get started? It's now under the testing library namespace, so npm install, and then /React will give you the React implementation of the testing library. Okay, so some key utilities that this library provides. The first one is the ability to render your component. So this is almost always needed. Straightforward, you import it and you can render it. The next one is, we know that when we write our tests, it's important for us to clean up after a test. So we can free up resources for the other tests or the other programs we run. This was initially, before a few months ago, what you really do is in your Jest config, or you can have a setup test file, basically calls a script, and that will take care of it. So it will run the cleanup after every test. But now with the latest versions of the library, you don't even need that. It happens behind the scenes automatically. I think with version 9 and above, that's a change that they made. So you get it out of the box. You don't even need this stuff. So different queries. What can you do? So remember, we talked about rendering components and dealing with DOM nodes. So how do I access them? So the library provides a set of query functions that you can use. I like to call these guys a prefix, because in the next slide I'll explain what the suffix is. So get by, find by, and query by are basically a way of you querying and getting the element that you're looking for. Get by and find by. Find by works with async requests, and query by is basically, it fails gracefully if nothing was found. Whereas get by needs the exact match, otherwise it throws an error. Get all, find all, and query all is the same, but for the multiples of getting multiple elements and checking against that. So this is a prefix. The suffix is, what do you want to query for? You can query by label text. So if you're dealing with form elements, you can query for the label text. You can query for the placeholder text. You can query for text, and this is basically any text that would appear in your application. You can use this function to look for that specific text. Display value, alternative text, title, role, and then finally by test ID. So what's this one? So the principles behind this library was to say, hey, let's do everything like how the user would find it. Now let's say by test ID is the only exception. And the exception is because for this to work, you actually only want to use it if you're not able to use any one of these to achieve what you're trying to test. And there are scenarios where you really can't go up with anything on the screen, and you may have to test that component. And in that scenario, what you do is you create an HTML attribute, data-test-ID, and then you give it a value, and then you can use by test, so get by test ID, and query for that. But it's recommended only if none of the approaches are possible, mainly because that HTML attribute will get shipped to production, right? So I think that's like the one caveat and the one exception. How do we fire events? You can do that. You have a fire event function and a fire event star. Basically, that has a collection of your common events that you find. You click the events, your mouse key ups, key downs, and things like that. Async requests. A couple functions: wait for element, wait for DOM change, and wait for element to be removed. You get all of these out of the box as well. All right, cool. So we got our building blocks. We got our queries, we got our events, and then we got our async requests. So now let's look at a code snippet where we can see how we write one of these tests. So this one is from the official web page, and they have an example over there. So I'm going to zoom in for each section. First thing you want to do is you want to basically import the key functions that you actually need for your test case. So you need render. In this scenario, they need fire event. Cleanup is no longer needed with the newer versions, and wait for element. And then, so you're basically importing, you're testing for an asynchronous request, so importing the Axios mocks. And then finally, the component that you want to test. So the first step is you set up. So in your tests, there are 3 steps. With the good unit tests, 3 A's: arrange, act, and assert. Arrange is setting up your data, act is invoking the actions, and assert is checking, hey, is it really returning, or is it doing what it's supposed to do? So in this case, the first one, what we do is we want to render our component to begin with. So, and then it returns certain functions. So what I'm getting is I want it to return get by test ID, because in this example I'll be using them for assertions. So first thing, with the URL, you render your fetch component. Second thing is you actually make the asynchronous call. So here, so the way this works is there's a page and there's a button called load greeting. You want to click that button, and that button will then make an asynchronous call, get certain things, and render it to the page. That's what the component is doing. So first thing, you want to simulate that. So you're doing fire event click, find that button, the initial button, and click on it. And now, wait for the element and see what it returned, right? So that's your, here's where I get access to the greeting text component using get by test ID. And here, I'm doing my assertions. So now I'm checking, okay, was it called, how many times was it called? So it's called 1 time. What URL was it called with? And then I'm checking, hey, what was the greeting text? You said load greeting. The greeting text I expect is to be hello there, and I have it. Did it also make sure that there was a button called OK, and was it disabled, right? So this is how you would wrap up that text. Now, if I go back a couple more slides, I mentioned, I didn't really talk about this. So Jest gives you, out of the box, certain matches that you can use to validate elements, but not all of them. So the community has now created more custom matches that we can use. So that's what this library is. So it's the Jest DOM library, and you can import that and use functions on there. So to have text content is actually from that library. So you're basically checking against, hey, there's a custom matcher saying, hey, is that text there, right? All right, so, yep, and this was recently also moved under the testing library namespace, so you can find it in that namespace. All right, so here's a component that I wrote and an example. So basically what it's doing, it's making an asynchronous call, getting a list of photo information, so getting a URL for where the photo can be found, and then who the photographer is, the author, and more links. So I just got a snippet here. I'm spinning through it, and then displaying cards based on the image source and a title. Okay, so let's write a test for this component. First thing is I want to import the necessary function that I want. So in this case, I want the render and wait for element. And then I mock my Axios request. So I'm making an asynchronous request. And then I will have my structure of arrange, act, and assert. So when I'm mocking, I need to provide what my return data structure would look like, so I can check against that. So here is basically that structure. So it's checking, okay, what's your author URL, what's the ID, things like that. All right, so now I'm going to make the call and make sure that it's actually returning the data structure that I just mocked. All right, so then you render your component here. I'm using get by title and container. And finally, I can say, all right, so I was expecting 2 elements to be rendered, so I'm waiting for them, and now I get the John Doe element and the Jane Doe element. So I can, next step, I can actually run my assertions. So this, before we go to the assertions, the same action, what I'm doing here can also be achieved with find, the find by element. That's what it's doing behind the scenes. So instead of all of that a little bit complicated code, we can just do this. Find by and the find by title. Yeah.
What's the difference between, could you go back one, sorry?
Yeah.
What's the difference between wait for element and just regular wait?
So wait for element actually expects the element.
Okay.
Wait is just waiting to see
until it shows up.
Yeah.
Okay.
All right. Yeah, and then finally, I'm doing my assertions, checking, hey, how many times was my request called, what URL was it called with, and here I'm using a custom matcher again to check, hey, did it actually render the background image, right? So those are my assertions. All right. Any questions so far? Cool. All right, so everything passed. Good stuff. So the good news is, I know this is a React meetup, so all of you guys are probably using React or very interested in React. But if you have friends using other frameworks, tell them that this testing library is not just a React thing. It's actually could be used by Angular folks or people who are doing Vue, or even if you're writing vanilla JavaScript applications, you can use the power of that as well. All right, so I'd like to end with asking you all, what do you think the biggest benefit of testing or unit testing is?
Not having a manual test?
Yeah.
Okay.
Being able to change something 6 months later
Yes.
and not being afraid of it.
Okay. So confidence, right? What else?
It's a lot easier to test out the edge cases inside of these unit tests rather than having to test everything in the manual test.
Okay. Yeah. And I think reduce bugs, right? So that's a big one. But honestly, for me, all of those are great benefits. But really, I think the biggest benefit of testing and unit testing is that it makes you a better programmer. Because you're now forced to refactor your code. Every line of code that you write, you're kind of forced to think about it, rethink it, and improve it. And this is a continuous improvement journey, right? So as a result of being good at writing code and writing good design, I think then you'll start seeing lesser bugs. You'll start seeing improved quality, right? So to me, I think embracing testing and unit testing, I think really helps your career go a long way. Cool. I'd like to leave everyone with a quote that's dear to my heart, which is actually found in my office. We have these motivational posters. Quality is doing it right even